Hi and welcome to this video about creating your own generic REST NED. My name is Hua and I'll be guiding you through the steps. Besides this video, we also have an article, Generic NED Development, which explains how you adapt this demo NED into a NED that speaks to a device of your choice. We also have a reference txt file which lists all the details of how it's related. The difference between the article and the reference is that the article is not too technical, while the reference is very technical. The demo NED is the NED we will be demonstrating and adapting today, but once you have done all the adaptations, how does such a NED look like? That's why I have also provided a test device NED. Test device NED is essentially demo NED, but I have replaced all the device name, device short name, and the vendor's name with other values, so that you can compare how an original demo NED looks like and also how a adapted NED looks like. The demo NED has lots of code which is auto-generated, and when you adapt your NED to a new device, there are two steps. The first step is the bare minimum adaptation. This you absolutely have to do in order to let the NED talk to a new device. But this adaptation is a bit simple, and if you have a setting with several NEDs, then you might also need to update other details such as namespace, ID, and so. And that's where step number 2 comes in. But both the article and the reference file explains both step number 1, which is mandatory, and step number 2, which is optional. So, when you want to develop a new NED, what do you need to do? And there are a few steps. The first step is to understand how the device works. A NED essentially take NSO commands and adapt it to commands which the device understands, and then stores the config from the device. So you need to understand how the device works and also what config you would like the NED to support. And this config which the NED is to support, how is it structured? What's the hierarchy between the config? This you need to understand, and you need to model it in a YANG model. Once you have the YANG model in place, you need to write Java code that creates these commands which the NED will send to the device. I will show you all those steps with examples, but for the first step, let's take a look at how this device works, which the demo NED talks against. In our case, it's an instance of Bitbucket, which runs at localhost. And what I'll be showing is how to get configuration, create configuration, and delete configuration in this example. So let's start by fetching some configuration from this local device here. This curl command fetches configuration from localhost at this port with this path. Let's see what we get. We don't get anything because there is no projects. Yes, the config we're looking at is project, and it should be inside the value. We only get information about limits, size, and other meta information. So let's create a project. Post. I'll create a project with the name project name and the key project key to this path with the post command. It's important to pay attention to these details such as path, body, and what request you send, because this is what the NED needs to mimic later. This is the response returned from the device, which the NED might need to save depending on if the information is needed for later. So let's take a look now with the get. Now we see that the project we just created is returned to us when we send a get within the values. Let's delete this project now. Now that the project is deleted and we do a get, the value is empty as expected. We don't get any project. When you create a new NED for a new device, this is what you need to do. You need to experiment with the device to see what command does it take, but also how does the configuration look like when you fetch the configuration, because that is what you need to know when doing the YAG model. Let's take a look at the YAG model. Demo NED. I can also explain that in the demo NED folder you have quite many files. Changes just list the changes between the releases. Doc internal and load.io and package metadata are NED internal files which the NED use. Package metadata and doc internal contains information about the NED. Private jar and shared jar contains jars which the NED uses. This is a generic REST NED that will use JSON and HTTP libraries, and those are stored in a private jar folder. README, you can take a look at the README. It's just a simple README, and you can add information here which might be valuable. But in this step, what we will do is that we will modify the files within the source. So let's take a look at the YAG model first. Most of this you can use as is. What you need to adapt is often the lists and the leaves. You might need to delete it and recreate it, write your own, depending on how the configuration structure looks like. The information above, it's about namespace and prefix. You could reuse it, but if you use many NEDs, then it's good to have different namespaces, and this is described in step 2 in the reference file. But let me explain the YAML then. So what NED developers usually do is that once they figure out how this config is related, they try to create a model. In this case, I would say that the device can contain many projects. Each and every one of the projects has a key which is unique. That's why I create a list which I call projects, and the key, so that I have a unique list entry with some unique leaves. I also know that the project requires a name. That's why I have mandatory true statement here. I also want to support the description leaf because that's the use case. But I also know that it's not mandatory, so I left that out. There are many more values to projects, but we don't need to support that in this first demo, so I have not added it in the YAML model. To answer the question, when is a NED done? The answer is it depends. The NED only supports all the use case which previous customer has required. So unless the NED already supports the whole config tree and every possible use case, then it's not done, and it's a continuously developing NED. We develop as we get new use case which we don't support. We will not cover repos in this tutorial, but I can explain a little bit. I know also that the one project can contain many repos. That's why I have a nested list within the list project. I also know that repo has a value called slug, which is mandatory. So that's why I have the mandatory true. Depending on how complex the config structure is and how nested it is, a YAML model could be very, very large. This YAML model is quite simple, but Some NEDs which has been around for a while, their YAML could be around 10,000 to 15,000 lines of a YANG. Besides this YANG, which describes the structure of the configuration, there are other YANG files as well, which I can describe briefly. We also have the stats YANG. The stats YANG contains information about all the live status call the NED supports. A live status call is like an RPC call. The NED needs to issue a call to the device and then return the response. Meta YANG contains information about NED settings. NED setting is a way to adapt the NED behavior depending on how the device would behave. An example is that some configuration takes a long time to load, and some customers don't need that configuration in their use case. So if you always support that configuration loaded, then it will take a very long time for all the customers. So most often we create a NED setting called maybe skip a config X, where config X takes lots of time to load. So if you need config X, you in the NED setting specify that you need it, but if you don't need it, you specify you don't need it, and config X will not be loaded, and hence NED will work quicker. The ID YAML file, it just stores information about the NED ID. NED ID is what makes the NED unique among all the other NEDs. So if you have multiple NEDs in your setup, then it's important to pay attention to NED ID so that your NED is unique and is the correct NED you're referring to, so that they don't get mixed. Now that we have the YAML models in place, the next step is to create the Java code that handles the logic when contacting the device and creating the correct commands to send to the device. So let's take a look at the Java file. This is a generic REST NED that uses JSON and REST, the REST API. The NED itself is this file, JVX NED generic Java, but we also need helper class to help us convert between JSON and XML, and that's where we have JSON XML utils and JSON transformer. We also need a way to create REST connections, issue GET, posts or update requests, delete requests as well, and we also need to close the REST connection. That is handled in the REST connection class. But let's take a look at the Java class. Every time you do an action through the NED, if there is not an existing connection, then a new connection will be created from the NED to the device. This means that the method new connection will be called, and this new connection just creates an Java instance NED generic. And we can take a look at the constructor. So what we usually put here is code that handles device initialization, login, and also setting up connections. It could be SSH connection, could be REST connection. It depends all on the device. So for instance, in our case, for this NED, we set up MAPI, which we use to talk to the NED's own config database, the CDB. And then we also create the REST connection, which is to be used when we communicate to the device through REST. But some devices also requires additional setups like logging into prompts, fetching default config, and so in that case you need to do it in the constructor. I showed you how to get config with a get, how to create config with a post, and how to delete config with a delete. And the NED, if you want to get config, you will issue a sync from, and sync from will call a Java method called show. And in show you then have Java code that fetches the config from the device and process it and loads it into a CDB. If you are to set config or delete config, then you would need to issue a commit, and commit will call the Java method prepare, which creates the command that needs to be sent to the device. If you don't want to send the commands, but you just like to see how it would look like, you could issue a commit to dry run, which then calls prepare dry. Prepare dry does not send anything to the device, it just shows you the output of what commands it would send. Let's take a look at how show looks like. It all depends on the device. So for every new device you need to update show, prepare and prepare dry so that it handles the device you want the NED to talk against. In this case, when I started to develop this NED against the device, I experimented a bit and then I implemented this method. I can explain it briefly what happens. Map is used to set and read configuration from the CDB, configuration database. I know that this device talks in JSON. It returns configuration in JSON. So what I do here is that the REST connection I created earlier, I just use it and I issue a GET request to this path. This is information I got when experimenting with the device initially, before writing the YAML, before coding. And then what I do here is that the device response, which is stored in projects all, I fetches the values array. Remember that it looked like this if I did a curl get. All the information is stored in the values array. Now it's empty because I deleted the project, but before we had the project here. After we sent post, then when we did curl values, it was inside here. So what we do is that we fetches the values containing all the projects, and then we also know that the projects contain repos. So what we do is that for every project we fetch and take a look at how many repos they have. Depending on how complex the device is, you might need to have more code here that would handle special scenarios, exceptions and such. But in this case, this device is quite straightforward. So what show does is that it fetches the JSON and then filters out what we need. In this case, name, key, description and repos. Sometimes repos is not defined. Then we have this instead, no repo. And then we store everything in the load all projects. And then what we do is that we have JSON now, which the device has sent to us and which we have filtered out. The CDB accepts configuration as XML. So what we need to do is to convert this JSON into XML and then adapt XML in a format which the CDB can understand. So this is what I do here. I take the JSON XML util helper class and convert it to XML. And then I use two helper methods, move keyleaf to top and modify to NCS format. These are NED internal methods to process the XML in a way which the CDB can understand. And then the most important part is here, loading it into the CDB. I use mappy, load config commands, and then the command flag just shows. You can specify different options when loading into the CDB, and it depends on the device, it depends how the config looks like, and it also depends what you want to achieve. But in the demo NED, all this is already provided as is, so you can use it and see if it works. If it works out of the box, then no adaptations need to be done. Let's take a look at how prepare and prepare dry looks like. Remember that when we want to send a command to a device, we do a commit. If we just want to take a look at how it would look like, we do a commit dry run. Commit calls prepare. What prepare does is that it calls edit and then it returns a response, or if something unexpected happen, then it throws an exception and we receive an error. Edit. Prepare dry similarly calls edit and gives a response or throws an error. Difference is that in prepare dry we provide a string builder. Remember that prepare dry does not send any config to the device. Instead we return the output of what we would send. This output which we would have sent is stored in the string builder, which is then returned and printed out. And once again it calls edit. What edit does is that it, based on what configuration you modified and what operation, it creates the corresponding device command. How do edit know what has been modified and what config has been modified? Thanks to NED ops. NED op contains information about the operation and about configuration. So what we do here is that we iterate through all the NED loop and then we take a look. Was it a creation? Was it a deletion? Or was it a modification? And then what we do is that based on what operation it was, we call the corresponding method a create, a delete, or update. And this is where it's important to pay attention that similarly to show, depending on how the device behaves, you need to update, create, delete, and update to adapt the NED to the device. This demo NED supports how the device I'm demonstrating works. If the device you are using differs a lot, then you need to rewrite most of the part. But let's take a look at create. What we do here is that nav node contains information about the config which has been modified. So this is auto-generated and it just fetches the configuration and creates a JSON body for me to take a look at. You can troubleshoot the NED with logging. There is two logging files of interest, the Java log file and the trace file. I will explain more about that later, but this log debug essentially prints out information in the Java file. I will explain more in detail later. And then what we do here is that we take the JSON, and in this case the JSON does not need to be adapted so much since the device is compatible with this JSON directly, so we don't need to modify it. All we just do is that we take a look. If it's not null, it means that there is something to send, and then we create. The only modification we use is that we replace this word, we remove it, we replace it with nothing since the device does not want this word, but the NED sends this word by default. And we take a look. The string builder which is used in commit dry run, prepare dry. If it's not null, it means that this is a commit dry run. You don't need to send the command, you just need to show how it would look like. So we just add the config into the string builder and then we exit the method, we just return. If it's null, it means that okay, this was a real commit. We need to send it to the device. What we do is that we just do a connection post to this path. And remember that when we wanted to create configuration, we issued a post with data to this path. This is what we're trying to mimic here through the NED. We do a post to this path with the JSON. I can also delete and update works in a similar fashion. I can just show you delete as well. So here we would send a delete to this path. And let's take a look at delete then. Similarly, delete just fetches what needs to be deleted and decides what method it is, and then it checks if it was a commit dry run or if it was a commit only. And then depending on what method it was, it either do a post, a put, or a delete, as you can see here. The connection.post, the connection.put, or connection.delete, and then it sends. And I would like to emphasize once again that depending on how your device works, this needs to be rewritten to suit the device. Now that you have seen how the code is like, let's take a look at the NED when you're actually using it. What you need to do after you have experimented with the device, understood the config structure, created the YAML model, and written the Java code to handle the device communication, fetching config, and what commands send, you need to compile the NED first. So let's compile it. Source, and we compile to make clean all. That's good. And then once you have compiled it, you need to create a NED instance out of this NED package. You need to do a setup. You need to set it up, and you do it by doing the NCS setup package, and package would be demo NED, and the destination we can call it test, but you can choose the name of your choice. Let's see, we might be having an SO running already, so let's try and stop it. Now that it has been stopped, let's start it again, but we load the newly compiled package into NSO. So we need to change the directory to test, and then we do a NCS with package reload. Start NSO and reload it with the package. Okay, good. And now we enter the NSO CLI. Okay, now we have created a. Now we would like to create a NED instance so that we can communicate with the device through the NED, and we can do it by going to a config mode, and then we do these commands. All the steps I've shown so far, and so it's summarized and also written in the reference file. So if you would forget or just want to take a quick look how it looks like, please consult the reference file. I'll write that here. Set devices device. It's the name of the device, so we can call it whatever we want. We call it D1. Config, not config, device type. Config is what you specify once you have specified all our necessary details for the NED instance. Device type, it's a generic NED, so we call it generic. You can also tab for autocomplete here, and it's a very good feature. So if you don't know what to write or if you're unsure, just tab and see what options you have. We ran at localhost port 7990, so that's something we need to set. So we set IP address, and this of course would be the IP address of your device and the port. We also need to set the state. So it's the admin state to unlocked. When we sent the commands, we had credentials, user, username, and password. In the NED, we store such information in off groups, so we will need to set an off group. Set devices off group. We call it group 1. Default map, remote name, that would be this, and remote pass would be pass. And then we need to link this off group to the device D1, and we do it by writing this command, off group G1 commit. Remember that I said that you could enable logging, and there were two logging files, the Java VM log and the trace files. There are many more logging files, but these two are the most commonly used when troubleshooting and debugging. You enable the Java logging files with this command. You need to specify the Java package, which can be found here. It's important to input the correct value here, otherwise you could enable the logger but you will not capture any logs since the logger looks at the wrong place. And then you decide what level you would like to capture and print. We can take Alt for this time. And then you also need to enable the trace file if you would like it to appear. The difference is that the Java VM file logs everything related to the Java part, and trace file logs communication between the device and the NED. What does this device send? What does the NED send? And what does the NED receive? Trace raw. And then we commit. What we do now is that we commit the information into a CDB so that it is stored. So let's fetch configuration from the NED now. We do it from SynFrom. SynFrom will now call show, and show will fetch the JSON, filter out what we need, convert it into XML, process it in a NSO friendly way, and then load it with MAPI. Okay. Let's take a look at what we loaded and fetch. Okay, we did not fetch anything, but that's not strange because there is no conf projects in the device now. We can take a look. We get nothing. Okay, so let's create a config then, or more specifically, let's create a project. Okay, let's see. Project 1, name project 1. Now I issue a commit run just to see how it would look like when I send it to the device. And we can see that we would send a post, since we want to create config, to this path with the name and the key. So let's do a commit. We would also like to see if the NED and the device is still in sync. So we can do a compare config to see if the config differ. It does not differ, and that's good. And now when we do a show, we see that we have project 1. When we look at the device again, we see that we have project 1. This is the project we just created from the NED. Let's delete the project and see what happens. Okay, so when delete our project, we send delete to this path. So what happens now is that since this is a commit run, prepared run gets called, which call edit, and edit in turn identifies this as a deletion and call it delete method. And now we do a commit, and then prepare gets called, and a similar course of action will happen. Prepare calls edit, and edit identifies this as a deletion and calls delete. Okay, let's see if we match the device now. Okay, there are no config diff and there are no entries. Let's take a look at the device. Get. Yep, there are no projects now. So the idea of the NED is to take what commands we write from the NSO CLI, translate it into commands that the device understands, and then send it to the device. And that's also what we as NED developers need to know. We need to understand thoroughly how the device works so that we can create a good YAML model and also create the correct commands for the NED to send to the device. Let's do a little bit of modification. Assume that I would like to log the JSON before I send it when creating it. Imagine that I would maybe like to debug the JSON. How would I do that? In that case, what I need to do is to modify the Java class. Create. So down here, this which I previously commented out, I can enable. I save it. So what we do now is that we just add a logger that logs something with the message test login JSON and prints out the JSON value. every time you update the YAML model, Java code, or anything else in that, you need to recompile the NED. Or more, or more correctly, the NED package. Make clean all. Now that I have recompiled it, I need to load this new recompiled package into the NSO. Request packages reload. That's good. And then we do a config. Remember that I added this in the create. So all creation now will log this test log in JSON, while deletion or modification will not log anything. Let's take a look then. We can take a look at the log files. Test logs. NCS Java VM log. Yep. Or we can also take a look at the trace log. We need to be in the correct folder first. Okay. So let's create a new project. We're going to create project 2. Yep. This is the JSON body to be sent. So this should also be logged. Yep. And what do we have here? Test logging JSON and then the body. This is as expected. In this example, the body is quite small, but there are nets where the body is many lines, like 100 lines, so something like that. Then it could be good to debug it to see what's wrong before sending it to the device. And all these other loggers, like connecting, REST connection, it's just Java loggers which has been automatically generated to keep track of where you're on the code and to make sure that the code works. And if it does not work, you can see where it broke. And in this case, you can also see that the trace file, okay, JSON output, it was a prepared dry, yeah, it logs what happened. It was a created and a value set. Let's do a commit. We prepare, commit, okay. During debugging troubleshooting, if you suspect that prepare is broken, then you can add logs in the prepare and then just look between the prepare logs. So you can essentially add any logger you want, anywhere you want, and then just debug through that. And if we look here, we see that, okay, we sent this to a device and then we got a response. And here it is. And then the trace file also logs the different methods we go through. Let's do a delete and see what, if any, logging happens. And it will not log anything since we only added this logger in the create method. Native. And as expected, the JSON body did not get logged. We do commit. It did not get logged. This demonstration is just a simple example of how you can take an existing NED and adapt the bare minimum so that this existing NED, instead of talking to the device it was intended to, can talk and work to a new device which you choose. All the things I've explained and described here is summarized in the reference file in a non-technical way in the article. Step 2, which more or less adapt the whole NED so you can use multiple NEDs, is detailed in the reference file. And also you can compare the demo NED with the test device NED to see what replacements have been done so that you can transform the demo NED into another talks to the device which you would like it to talk to. And that's more or less all you need to do for this first mandatory step 1. If you have any questions or so, let me know and I will answer it as good as I can. Otherwise, thank you for watching and have a nice day.